Hi, my name is Patrick North, and I'm going to talk to you today about background characteristics and conditions for imaging systems. So we have for your imaging systems, the system that you have could be built specifically to collect on a particular target of interest. And everything could be set up just right, but that doesn't guarantee that you're going to have a good picture. The idea is you have all these background characteristics and conditions that could mess that picture up. And there's a lot of categories of those, and I just wanted to go over a few of the more common ones. So for example, I could have a bright red fire truck, and that's what my system's designed to collect on. But if I park that red fire truck on a bright red parking lot that has the exact same paint color as the fire truck, I don't have any contrast. And you're never going to see a target defined against this background if they're the same color. You're never going to be able to pick that needle out of the haystack. In addition to the contrast, you have clutter. So let's say I've got the perfect target, the perfect imaging platform, but I'm parked on a checkerboard. And this checkerboard has a whole bunch of different dark and bright spots on it. Well, I might have fantastic contrast from some angles, but I'm not going to have any contrast from other angles. Or maybe I've got really bright brights, really dim dark sections, and it's going to throw off the whole dynamic range of my image. I'm going to need to take those things into consideration. But besides just the intensity of the signals that are coming from it, I could also have elevation clutter as well. So I could have mountains in the region, and these could physically obstruct the target, or they could cast shadows that throw off all the signal from these. So even though I might have good solar elevation angles and good illumination conditions, if I'm imaging in a shadow region, I might need to adjust my dynamic range to actually see the contrast of this target against the background. But in addition to these, I also have the atmosphere. I have all these little particles in the atmosphere, and those are going to attenuate the signal a little bit from my target to the sensor. So I'm not going to catch every photon. I'm also going to have things like haze if there's a lot of solar scattering, or if it's in the thermal infrared, I'm going to have path radiance. The sky's actually going to be glowing, and I'm going to need to deal with those specific background conditions. I might have the best background, a nice flat background. I might have great atmosphere. I could also have things like clouds. I could, the same way the mountain could obstruct the target, I could also have clouds floating around, and those are another complete background object that could obscure my target detection capability. So all of these things are going to impact my target imaging performance capabilities and the sensitivity of my system. However, these are sort of a snapshot in time items. You also have things that are seasonal. So for example, throughout the year, I could have my summer months where I've got a lot of sunlight every day, and I've also got my winter months where I'm going to have a lot more dark times. Your system could be spec'd with a 30% solar elevation angle, and at some northern latitudes during the winter, you might never see a 30-degree solar elevation angle because it's just their winter time. The sun's never going to get that high in the sky. Or you could have monsoon season, and for entire months, those conditions are going to prevent you from taking the types of images of the targets that you're interested in. So there's seasonal variability. And you also have daily thermal conditions to take into consideration as well. You're going to heat up and cool down throughout the day if you're a thermal infrared sensor. But in addition to all of these things, you also have distractors. So these are the photobombs, where you just have something that catches a solar glint, and it sends so much target at your sensor that it throws off maybe your dynamic range, or maybe it's in the vicinity of your target. That could be a glint from just something in the background. It could be a retroreflector, or it could even be a bunch of kids in a parking lot shining their laser pointers at your UAV as you're trying to do a ground survey study. So all of these things impact your system performance and sensitivity outside of just your nominal imaging conditions. They're all things to take into consideration. And that's it. Thanks for watching.